Well, we have a green light up there. Everything's looking stable. I've got a feeling tonight my computer's probably going to be hacked in real time. Yes, and welcome to episode 77 of the CodeZone. And tonight we're going to carry on where we left off last time, which was a bit disastrous, wasn't it? We didn't really get very far at all because it took so long to install and configure the development environment. But the good news is I did manage it, and about 24 hours later I'd actually accomplished the project that I'd set out to do. So I thought tonight we'd have a look at several different aspects of this project and try and pick up where we left off. But in particular I'm looking at the server-side technology. So let's have a quick look who's in the chat. Magetsup is here. Hello, Magetsup. Bixie, hello. Good evening. Codlivian, hello. Engage Combat, first time chat. Hello. And, Bog Ooh. Hello as well to you. Right, it says here my bitrate is abysmal. I think it's just usual Twitch rubbish, so hopefully it's all coming through okay. Yeah, we've still got the new setup, and we're going to have a play with a few things called OLC LivePixel. Now, where do we start? Because I could start by just carrying on with setting up that build environment, but I think we'll see where the project is up to. And I will transition over to the bench camera. Look at this. Right, so if you remember last time, we said we'd have one of these LED matrices, which will then sort of illuminate with different artwork and pictures. And I connected it to, is this on the shot? Yes, it's just about on the shot. I connected it to one of these ESP32 devices. I hadn't used one before, so it was a bit of a learning experience getting it all set up, and we'll talk about some of that too. It is my intention, by the way, to make a complete YouTube video about this little project, because there's lots of interesting things which I'll sort of verbal diarrhea all over the place here, but the reality is they probably do need capturing, because I had a lot of problems getting this up and running. So I have a 16 by 16 matrix display, and at some point tonight somebody is probably going to try and hijack what's going on here. I'm surprised it's not already happened, but it would be nice if they could just all hold off until we sort of explain what's really going on. Because we're going to test some server-side technology. See the artwork on here, which I know you can't see right now. Don't worry about that. I've got a trick for that. This is going to be displaying various coloured pixels. And to do that display, I was going to create one of these meshes, this lattice, and put this screen on the front of it. And it worked quite nicely, but then I decided, well, do you know what? I've got a fancy 3D printer. I'm going to print the whole thing in one go. So what I'm going to do, just so you can see the display, is immediately turn down the lights on here. There we go. And I'm just going to change a camera setting as well. Now let me just pull up the camera. Because if I bring down the exposure, really down, so we can start to see some of the colours maybe. Oh, there we go. Okay, it's not bad. It's not bad. Right, now what I want you to do if you're in the chat or even watching on your phone or whatever is immediately jump on over to this URL. Right, this URL allows you to control what we can see on this display. I'm just going to put the filter on the top. Maybe that'll improve the image quality. There we go. Oh, losing a bit of focus. There we go. Right. So as you're drawing things on the screen, it's also appearing on my little digital display here. And hopefully you'll see it's actually, the latency is pretty good. I'm going to work out which microphone I need to talk into. I think it's this one. The latency is pretty good. And the nice thing is, it's a very simple sort of web, not even an API. It's been completely hacked to bits by very members of the Discord server. I'm just going to try and sit that down a bit, maybe make the contrast come through a bit more. And of course it's live in everybody else's browser too, so anybody that hooks into this WebSocket, and we'll have a look at how it works tonight, can sort of start to play tricks and games with it. And I'm waiting for TW, because I think TW is kicking around somewhere, who wanted to demonstrate one of the hacks they've come up with already. So as soon as it went live, about 20 minutes later, it was hacked to bits, and we'll have a look at why that might be the case. But the nice thing is, the server has been started once. So I'm quite proud of that so far. Right, let's have a look in the chat again. So we've got Standard in, hello, good evening, and Alta is here too. Herbal Dance, hello. Susan the Destroyer, ooh, watch out for that. Hello. So yeah, jump on over to that URL I've just put in the chat. Oh yes, you had the gradient script, that was right. So Bixie sort of threw, didn't quite understand the colours. I think people have worked it all out since. Alex, good evening, nice to see you too. I've got to remember to talk into this microphone. That's the one that's picking up my voice. So as you can see, somebody is dominating by trying to draw lots of red pixels. Now, invariably, people are drawing rude things and offensive things, and that is so. If anything like that pops up tonight, that is the nature of the world we live in. It isn't always perfect and smooth and nice and clean and pleasant and all those wonderful things. But I do encourage you not to try and make a mess of this, because I've got a feeling at some point somebody will start to run some of the scripts that they have created that will ruin the artwork for everybody. So I quite like this as a project, because I like the idea of having something that's completely out of my control, that's aesthetically quite pleasing. It's a shame the camera doesn't do it justice here. It's a really nice thing to look at. And so I will probably make the designs available. Who knows, I might even sell a few of them too. But we'll get there. It's nice because it's completely borderless and it's pretty nifty. And it's easy to set up. And the project's going to involve me also creating the circuit boards myself. It says OLC at the bottom. Oh, here we go. Right, so who was this? Straight away, somebody in there with a gradient script. Now, you'll see on the device, it's not actually as fast as it will be in the browser. And there's some good reasons for that. It's because I've been learning about how this ESP32 device works. Actually, the ESP32 is okay. That's about as far as I'm going to go with it. It's not by any means a fantastic platform for doing this sort of development on. I've got a long list of criticism, and I no doubt will go into some sort of diatribe about it at various points throughout the night. It's hobby grade, maybe, I think is the best way to put it. I wouldn't really say any serious embedded software engineers are actually using these devices for serious applications. It's a toy. All right, what's this? Oh, we've got some words going. So you'll see now the display. This is interesting. So on the website, I'll tell you what I can do, because I should have done this first time around actually. If I just pop this up, we can actually see the display live. And you'll see they don't line up. So what's going on? Why is that? The web browser is very live, but the device isn't. And it's because the device's Wi-Fi bandwidth is just not very high. And as people are spamming it with thousands and thousands of events to do things like this, it's only receiving them one at a time. And on Wi-Fi, it queues up. So your browser's connected via the Ethernet, whatever. It gets it very quickly from the server. But this device, it gets a sort of a big long queue of things, and it can only really update its display at about 20 frames per second. And it's got to share those resources with other things going on. So what I'm going to do, it's very good that it says hi. I'm just going to power it off. Right? And I'm going to power it back on again. And what this will do is it'll sort of automatically then connect to the server and straight away get the latest state. And once it's got the latest state, providing nobody's just immediately spamming it with video again, we can see that it becomes quite live. It's intended for single pixels. And that's one of the things we can talk about later. I have not put any sort of rate limiting on. There's no sort of blacklisting. There's nothing really to stop people from abusing this. At the moment, just the goodwill of the fantastic one-learn coder community. However, hopefully you can see it's quite live if you're playing with it. Let me quickly catch up with some of the chats whilst that's running. Where did we get up to? Bixie, you got the gradient skip. Yeah, yes. I think you didn't get it misaligned. I think you assumed it was full RGB and it isn't. Seuss hex code, yes. Yes, it is pretty cool. Very fun to play with. It is, right? It is very fun to play. It's been very satisfying to sort of put together because it's just a shit. I can't photograph the thing. I've learnt a lot about white PLA plastic. White PLA plastic is highly absorbent of red. So every time I photograph this, it looks really blue. But to my eyes, it doesn't at all. And to everybody else that sees it, it has this really quite beautiful aesthetic glow about it. It's very nice to look at. It's smooth and just all the pixels have a slight contour to them. It looks really nice. But I just can't seem to photograph it properly. This camera is not doing a bad job, but you see, where it is white, and it is white to me, it certainly looks blue on the stream. How does it look on the code cam? Well, I don't want to pick it up just yet and move it around. We will have to do some of that. Every camera I've tried, except for my friend's Samsung mobile phone, which obviously does some voodoo to enhance the image, seems to get it right. At first I thought it was like a white balance problem. It seems to be more than that. Oh, what have we got going on here? When you see lots of things changing like this, invariably somebody started to run a script, I think. Good. You've been deleted. We see that's the harsh reality of this art project, right? You can go and create something beautiful and then immediately somebody can come along and ruin it. Now, what I will say is I'm currently not tracking anything at all either. I think it's a good idea to, when we launch this live, to actually have sort of a history recorded of everything. And at any point you can go and view the entire history of the project. Oh, here we go again. Oh, that's pretty cool. So yeah, somebody has written a script to find images. Now it's only a 16 by 16 pixel array, but if you squint your eyes just enough, you might be able to make out what that should be. That's look pretty good. Yeah, knowing the internet, it's all bad. So I do actually need to put in some sort of restrictions. And I thought tonight we'll have a look at some of the code that's gone into this. But part of the project was to be to refactor the server code. The server code is a complete hash. It was a throw together just to make something work. It's got old bits of other projects in. And I thought it'd be interesting to go and sort of refactor this and talk about some of the things that are on it. Now, I don't know at any point how many people are actually logged into this. So whether it's 3 or 4 people at the moment, not a clue. But yeah, see, it's actually like really quite nice and responsive when it's not being saturated with bad Apple, for example, or Rogue coming along and blinking a pixel constantly in the corner. You're trying to do everything else. One of the things that nobody's really done with it yet is you can actually respond to it. So if you can communicate with your like people are doing, so sending it pixels, of course you can receive the pixels as well. And nobody's yet done something which responds to pixels being set. So I thought it'd be cool to have perhaps like a cellular automata game of life or something like that, script running somewhere, or fireworks. Every time you click, it sort of explodes with different colours in the background, or something like that. But as you can see on the device itself, it's not a very fast update rate per pixel. Which does unfortunately mean via Wi-Fi and the mechanism I'm using, sort of running video on it doesn't work very well. But in the browser, it's pretty quick. I think you're going to run out of space. This. Yeah, TW. Sadly, it wasn't just you. Have you got your bad Apple one good to go to run in the browser? Is that something we can all take a look at? Because what I can do is jump over to my main monitor view. There we go. And if TW runs the script, it should come up reasonably live. So TW is, of course, somebody had to do it. Doesn't look that live, TW. Oh. There we go. So, of course, somebody had to do it. And I'm guessing it won't be long before somebody's running Doom on it as well. Now, it's a shame you can't see the live update. It is lagging. You can sort of see it drawing lines. I'll bring it over in a minute so you can have a look. But just wanted TW's rendition of this happening in real time. And of course, you can, if you'd logged into the application, you'll see it doing it as well. So I'll just flick back to the bench cam just for a second. And so you can see where it's up to. So it is trying, but because it's being saturated with pixels, it's not that fast really. But I still think it's pretty cool. I made my program to run Bad Apple Blast the music. Oh well, that's your problem. And you put it back to how it was beforehand. That's very kind of you. Right, so what I'm going to do is, I think we'll stay over in monitor view for a second. And I can leave that over there. start having a look at some of the code that's going. So where did we end the last episode? We were looking at this design environment. So this is a distraction. I'll tell you what, if you want to have a look at that, of course, just go to the URL. I'll paste it again. And that way, anybody that's joined the chat since can just sort of go and have a look. Whilst I get that one off the screen for the time being. Right, where's all my lights? My lights are missing. There we go. Oh, it's better. I can see what I'm doing now. So we were having a go at trying to install this software, which was this recommended VS Code dev environment for the ESP32 platform. And the truth is, don't worry about this, it's not revealing anything that it shouldn't be revealing. And it was a real pain because it took a long time to install, and then there's absolutely nothing intuitive about how to use this environment. It took about 3 or 4 hours of tinkering about and getting things to work, and there's still a lot of things I'm unsure of. For example, I struggled to open the project. Each time I boot up the environment, I can't seem to find just something to click on to load that project and work with it. I have to sort of go through this additional route of loading some other file which is connected to the project, and then waiting for the ESP IDF welcome screen to appear, and then I can, it's just all a bit clumsy. But I will say this, once it's up and running, it's actually quite a pleasant development experience. If you've ever done sort of embedded systems, I've got a special camera. If you've ever done sort of embedded system stuff, you'll know that most of the dev environments are truly awful. But this one is not too bad at all. And it's not too bad because it gives you a lot of information. The debugger kind of works, but what's really nice is it's got this sort of, I mean, this is part of the problem. Right behind here in these tiny little buttons is where all the interesting stuff happens. You think you'd make this sort of big and visible and obvious to start your project, but no, they've hidden them in these little tiny bits here. Right, so let's just have a quick skim through some of the code. I broke it up into sort of 3 main components. The first was the main application, and we'll talk a little bit about what's going on here. And then there's 2 other components. The first is one that handles the Wi-Fi. I broke them out into, not into classes, but I broke them out into separate sort of units, as it were. It's in C, just to keep things a little sane, rather than having it all dumped in one big file. And I kept one that was the display. So we'll just quickly look at the display first. No, I'll tell you what, we'll look at the main example first, because one of the things that I found really frustrating about this environment is, wrong camera. One of the things I found really frustrating about the whole ESP32 thing is it's absolutely hobby grade, right? It is nothing like working with an embedded system that I'm familiar with. So if in sort of an industrial setting, I'm used to sort of getting a chip, a big user document of functions, and usually some application notes that tell you how things work. As best as I could not reduce the ESP down to absolute bare metal. That was my first problem. It always installs this concept called FreeRTOS, and I'll just jump back to the main camera here. So it always installs this thing called a real-time operating system in the background. And I tried, and I thought at one point I'd managed to successfully rid myself of that restriction, but no, it's actually still there. Even if you think you've gotten rid of it, it's still there, and it plays a role in what's going on. So I was disappointed. I was about to bin off the whole project. I was about to bin it all off. I keep going to that camera. Why do I go to that camera? That one. There we go. I'm still learning this. I was about to bin it all off, and I thought, I'll jump back onto the embed platform, which is a little bit more familiar. And I realised, no, let's stick with the mission. The mission was to try and learn this platform because it's very available, it's very cheap, and lots of people can use it. So I stuck with it, and I thought, right, if I've got to play by its rules, then that's what I've got to do. So, knowing that, bit bashing is out of the question. You can't do it. It's impossible. You can't do anything really with a time resolution of any better than 10 milliseconds. Now that's per task, and the tasks can do better things. But the timing requirements of the LEDs, you need resolutions of about, 10 to 100 nanoseconds. So it's quite a drop. That means you've got to start using weird and obscure peripherals in unusual ways. So actually, to communicate with the LEDs, I'm using a built-in LED library provided by the ESP32 vendors. But they actually hijack the sound output capabilities of the chip. They hijack it with some fancy additional waveforms, and they basically bluff bit bashing by playing music out of the sort of the sound peripheral on the device. And that's the only way they can get the timing accurate. Let's have a look at how does that do that? How do they provide those utilities? I created this thing called a pixel. We're familiar with pixels on this channel, and I created a handful of images. Sorry, a handful of functions. It's a real-time operating system, so we had to give it something called a task, and that's what it goes away and chews as. It's basically a thread to the rest of us. It's coarse, to say the least. I created some basic functions just to allow me to interact with it. We can have a quick look at some of these. Everything's hacked together. This data up here, by the way, this is the Mario sprite you saw at the start. So my image task is just a loop. There we go. And it's just telling the ESP system, run as fast as you can. You just keep spitting out LED update signals. Now, I've remembered to bring my oscilloscope home from work, and I'm not going to set it up for tonight, but we will do at some point in the future and actually have a look at the signals that are going out and see how that they're being manipulated. I then created a function called send image with a divisor. So one of the things I realized very quickly is that these LED matrices are bright, really bright, and they consume current. Literally, we're up there in about 4 amps. If somebody came along and set all the pixels to white, it would actually cause me power supply problems, and of course it gets hot. There's nothing to stop things from getting problematic. So I actually restrict all of the writes going out, and I do that by basically dividing by 16. Would you believe the brightness is bright enough to see? Somebody's put the C minus logo on the display at the moment. Just having a look. So they're so bright, I had to reduce them down, and I thought, well, a safe value, something that's pleasant to work with and look at, was about 16. So everything gets divided. I have a set pixel function now. As you can see, it's got this beautiful address here. Remember, in one of the old OLC mottos is y times width plus x. Well, that's exactly what we're doing here. It's y times width plus x. Now, the pattern of the LEDs on the matrix is serpentine. So every other row, I need the x-axis to flip, and that's basically what this line is doing. I'm sure there are some code ninjas out there that could come up with a far more elegant way of producing that line of code, but hey, it works. It's fine. Set pixel goes and crudely writes the pixel value to this location in the image array. There's no sort of thread protection being put in place here. Frankly, because I just don't care. I can go and make it critical sections. I can have semaphores and mutexes and all that sort of thing. But it doesn't matter. There's nothing dangerous going on. If a pixel gets updated slightly later than it should be, it doesn't matter. So I'm not bogging it down with complexity. I created a function fillRect whilst I was testing, just to fill the rectangle. Right, now this is the code they provide in order to start up the what they call it, this LED strip. They know that people buy massive bundles of these sort of NeoPixel things, and that people want to control them. There was a problem with it, and it was a problem after a lot of Googling. Didn't find a solution for, but I came up with a solution that seemed to work. I'm just quickly looking at the LivePixel display, see what's going on. It's all green with a white square on it at the moment, or somebody's drawing a white square at the moment. Good, well, it's still running. It was easy enough to set this up. You basically tell it what GPIO number do you want. In this case, it's GPIO 5. I don't think you can actually see that on the screen. I'll show you that in a minute. That's just one of the pins on the breakout board. And the number of LEDs, well, I have 16 by 16 in my matrix, so that's 256 LEDs. Right, the rest of this is to configure this LED strip. Now, when you start doing some digging on this, when you start actually digging into what people are writing about how to do pixel stuff with one of these ESP32 devices, you suddenly start to realize literally nobody has been that successful with it. And when people are successful with it, they don't really tell you how they did it. And that's one of I think the biggest criticism I've got of the whole ESP32 project and ecosystem, and to some extent Arduinos and Raspberry Pis and all that, is there is a lot of rubbish out there on the internet about how these things actually work. I think when people have dragged and dropped a few LEDs onto a device and think, oh yeah, look at me, I'm an embedded systems programmer, they then start going sort of spouting this knowledge all over the internet as if they are experts in it. And there's a lot of noise. And so hopefully with this project, and I'm going to make a couple of YouTube videos from this project, I can cut through some of that noise, because I know everybody wants to control fancy LED panels with an ESP32. It's a good project to do. And some people have managed varying degrees of success. So some people have managed to get just 10 LEDs working, some have managed 90. The largest number I've seen so far with one channel of output is actually 256, and that was this project. But I'm reasonably confident that you can do that. Actually getting the panel working using the built-in stuff wasn't that difficult at all. However, they provide you with various different ways to try and control these LEDs because they know that they're all flawed. You can't fundamentally bit bash what you need to do. There's just no way to do it. So you've got to sort of jump around what this free RTOS is doing in order to get any of this to work. So it's actually quite a nightmare. There's many hundreds of lines of code that go into configuring this audio hardware to try and output what you need. That's not unusual. Tricks like that you have to do in microcontroller land. It's just disappointing that you can't really sort of do it yourself. Right, so we'll move on. So that's basically what the configure LED function is doing. I thought it was pretty good. And when I first saw Mario appear in my sort of test images, I was really pleased with how it worked out. Let's hang on. So, am I stealing from work? No, I'm not stealing from work. SPI, no, SPI is blisteringly fast, but only over about 3 inches. So do keep that in mind. It's not really designed for long strings of LEDs, and that's where part of the problem lies. The protocol to talk to the LEDs is actually awkwardly slow. It's kind of in the 100 nanosecond region of signal length. Stuff has to happen, and you'll read it's so timing sensitive, you can't possibly do it without assembly language, and it's all just rubbish. That's fairly standard stuff in embedded systems engineering. It's difficult to people that aren't familiar with the environment. I'm just making sure I'm outputting the right information here. Good. Right, so we'll go back to my main for this. So there's a lot of things going on here. I'm just going to zoom out a bit, give us a bit of a broader perspective. Let's find the main loop. Where does it start? There we go. App main. So the first thing I do is configure the Wi-Fi. Now, the Wi-Fi is hard-coded into the device. It doesn't do anything clever. I've not got to sort of synchronize it with Bluetooth and code it up with your phone and all that sort of thing first. Don't quite know how I'm going to make the Wi-Fi customizable, but I'm sure we'll find a way. It's interesting. Bit Looney has video on LED strips. He made a few on the ESP32. Yeah, I mean, lots of people have done some similar projects. I'm not claiming any originality in this at all. For me, it was tying together using my 3D printer, doing some basic electronics, getting back into making some videos, and having some fun, learning some web development, because actually I've never done any web development until really the last few weeks, where I've been tinkering around with WebSockets and things. So the first thing my application does is call Wi-Fi Go. That goes and sorts out the Wi-Fi. I'm not going to show the Wi-Fi only because it's got some credentials in there, but it does. It's basically I've taken it verbatim from the website. They have some simplified Wi-Fi commands. I couldn't use them because they were too simple. Now, then I go and configure the display. We've just seen the display code. So that's all it's doing is configuring that display and then giving it a task. Now, this is the interesting line. This is the one that I think we want to pay some attention to. When I first connected up the LED matrix and had Wi-Fi on, I was thinking, yes, this is working, it's working. And then there was all sorts of noise on the LEDs. And I was thinking, what's going on here? I'd sort of see Mario there. Mario was static, and then I'd see a flash of green pixels, and then also, we've got the Amogus has appeared. I see a sort of flash of pixels, and then you go back to Mario again. So I wasn't corrupting the image memory. Something was interfering with the signals being written on this bus. And it turns out that it's the Wi-Fi interrupting the transmission of the signal. And you think this is why I'm starting to think, oh dear, right, this is a real nightmare, because there's quite a lot of complicated phenomena going on here in this real-time operating system, of which I have zero experience. How am I going to go about sorting this out? And I was trawling the internet. I was about to pack it all in. I was about to go, do you know what? I'm not going to be able to make this work. The hardware is not adequate for my needs. I need to think of a different solution. And I really got into the weeds of some obscure forums online to try and lots. If you Google Wi-Fi noise on LED strips on an ESP32, it is common. Everybody's having the same problem. And you sort of get all these people they go, well, I got it to work with my solution. And there's some basic rules, right? When I'm watching anything on YouTube, I will click the off button as soon as I hear any of the following three things. The first is, you should do this. And as soon as anybody tells me that in a YouTube video, it's off. That's closely followed by, you shouldn't do this. I really don't like being told what I should and shouldn't do by some so-called expert. I have to be very careful here, right? Because I make a point of not telling people what they should and shouldn't do in my videos, but I'm sure somebody will scrape through them and find the one situation where I did. Right. The third thing is anybody, if you do this in your videos, if you're going to create videos and you say this, so what you're going to want to do is, off, click, gone. And there's a lot of that sort of material out there in both video form, written form. It's just a big red flag that it's awful. So we shouldn't say this in our videos. I really wouldn't. I really wouldn't at all. I actually like watching the ones posted on the Discord server, but as soon as anybody goes, so what you're gonna want to do is, oh dear me. That's enough. So let's jump back to the code for a second. Had my rant about this sort of the community that grows up around these things. Well, what I discovered was that actually the ESP32 is a dual core device. Well, that's a really nice spiral that's just appeared. It looks great on the thing too. You can go and have a look at that again in a minute. What I kind of discovered is it's a multi-core device. There's two cores. And obviously the Wi-Fi was interrupting my LED strip task. And so what people were sort of hinting at is what you need to do is so what you're going to want to do is you should pin that particular task to a specific core, right? So it's kind of like setting the core affinity in Windows. I don't know what the equivalent is in Linux, but I'm sure it's the similar thing. You can set the process affinity, sorry. And well, I tried that and it didn't work. Nothing changed. I was pinning it to either 0 or 1, and this is the priority here, priority 9. I'm not quite sure what the 2000 was for. Oh, that was for the stack size. That was it. So I tried it and nothing changed. In fact, all I could do was change the noise levels. Then I started messing about with DMA buffer sizes. I got really stuck into some of the bowels of the LED driver and said, well, if I make these buffers bigger, perhaps the buffers are handled atomically, perhaps they don't get interrupted, and nothing. I couldn't make anything work. I managed to reduce the noise by playing with some of the buffers, but didn't get it to work. And then I thought, right, well, what have I got here? I've got the Wi-Fi and I've got my image task. If one's interrupting the other, clearly they're both running on the same core. So I went into one of the configuration scripts, and this is where things start to get a little bit complicated. Now let's see if I can find the configuration script. Because you click this little gear down here, and there's about 10 ways. This is what's frustrating. There's about 10 ways to config this device. And there's a lot of settings, which is reassuring, right? It does expose a lot of things to us to be able to use. And I went, was it here? This is where I can't even remember now. No, it doesn't look like it was that one. Scroll up a little bit. Not wireless coexistence. No, not that one. keep going. I went through, I can't remember what it was. I went through every single one of these. Every single one. TCP, no. I'll never find it again. Why is it not under Wi-Fi? Ah, there it is. Wi-Fi task core ID. And it was set to 0. So even though I was pinning my LED strip core to core 1, I just thought, you know what, I'll flip them round. Why not? Let's just throw this one out there. And I couldn't, nobody was hinting at this. So I did, I changed it to core 1. Immediately problem solved. So there's some sort of collision problem with how the ESP32 kernel, this FreeRTOS kernel, is handling sort of the distribution of these tasks. Either I've not grasped it right and I'm not really allocating per core, or they're not handling interrupts as cleanly as they should be doing. And so by throwing this to core 1, that's actually got rid of all the noise and made everything work very responsibly. So do get the word out there. I will mention that specifically in a video, because I know people will be searching for the answer to this. It really was not that easy to find. Because one of the things is, if you try to allocate the cores in software, it gets very complicated very quickly. Far too bewildering for me. One of the things I will stress is that even though it is a hobby grade tool, as soon as you go out of that walled garden, that ecosystem, it becomes a nightmare. And the documentation is not there to back it up. So digging around and just experimenting, this took a lot of effort and time, but I did find it. There it is. And it says pinned Wi-Fi task to core 0 or 1, and I pinned it to 1, and it doesn't interrupt anymore with the other tasks that are going on. Or at least if it's interrupting, it's not interrupting the other core, so that's a good thing. Let's just hang on, catch up with some of the chats here. Is that a 2012 Ibanez S520? yes, it is, Pixie. That's very astute of you. What marvellous knowledge you have there. Got your cheapo engraver, I'm guessing, is what you're meant to be saying there. You went to use with laser. Yeah, the software is awful. You should be able to actually control. I think you should be able to get a CNC thing up and running. A small G-code application. If you've not written one of those yet, you haven't lived. But they're actually reasonably available, and you can get some pretty good stuff completely for free, right? Lots of people have done G-code processors. Yeah, I think Rosso, that's right. So I was actually really struggling with it, but yeah, I persevered. I like that. I was waiting for somebody to get an emoji on there, actually. Let me just jump over to the bench cam again. There we go. You can just about see it. What's going to happen if I turn that off? There we go. Very nice. So, I mean, it looks fantastic, right? It's really quite colour matched now. I'm really pleased with the quality of this, how it's come out. Right. I'll leave that light off a bit, and we'll go back to CodeCam. There we go. So, well, I have to turn that on when I'm looking at the screen. It's just when you start getting to my age, not having a light on in the background. You know, I've coded in the dark for nigh on 30 years now, and I've ruined them. They're irretrievably damaged. Right, let's have a look. Where are we? So once we've created this task and we've pinned things to the correct cores, I then go and create what's called a WebSocket client. Now, WebSockets were new to me until about a month ago, and I started playing around with one. And I posted some code on the Discord server where I had a little application. People could move a cursor around, basically, in a Pixel Game Engine application compiled with Inscripton and thrown onto the web. Do you speak any Spanish? I'm afraid not. Not really. The biggest shame of my life is I actually abandoned other languages. You know, I lived in Switzerland for 6 months to learn French, would you believe? And that was when I was 11. And I went back when I was 12, and it's all gone. It's all gone. Do I speak any Russian? No, I'm afraid not. I don't. I'm unfortunately I am only monolingual. Sorry, I know that's like nearly everybody I know on the Discord is not natively English and can speak many different languages. Hello. So yes, WebSockets were brand new to me, and I got intrigued by them. They're like having a network port for your website. I thought that sounds fun. Let's have a play with those. And did that open up a full-on minefield of new stuff for me to worry about? So, in short, it's basically a network endpoint. It talks a specific language which is aimed at websites, so browsers can sort of talk with servers in a reasonably safe way. It's not perfect by any means. It's got some overhead to it, but it's consistent, and more importantly, it's really easy to use. Until, that is, you decide to try and follow the rules. We'll come back to that in a minute. So once I've created this WebSocket, that's you do that after you've done the Wi-Fi. So one of the things I just took a punt on, I had no idea how does it do it, is once it's configured the Wi-Fi, it's like you've plugged in a network card into the microcontroller, and I find that nauseating but also fantastically useful at the same time. Now, I don't care how this WebSocket works, really, or how it's connected to the existing. It knows that the internet is there somehow. There's a lot of black magic going on behind the scenes with this device. Once I'd sort of given in, I'd succumbed to the ecosystem. I just decided, right, okay, let's do it the way it wants me to do it. And lo and behold, things started to come together quite quickly. What does that tell you? So once you've established what the WebSocket should look like, you then go and create it in the device, and somehow magically data starts appearing, which is really nice, and we'll have a look at how that's processed. But fundamentally, I have a function called WebSocket Event Handler, and any sort of incoming data or information about the WebSocket goes and calls that function with some arguments. So then I start listening. There we are. So I start my WebSocket client, and then I sit in a loop. And all I'm doing is send image, which is that's not actually sending the image. That's a poorly named function. come to think of it, I think it used to. That's basically updating the image that's going out via the LED strip peripheral from the image I've got in RAM on the device. So it's the thing that's sort of moving memory from one location to another. Is it efficient? No. Is it? Could it be much better? Yes. But as I say, this is a hack together, and I'm going to tidy all of this up and before I sort of film it, and actually maybe put in some error handling and things like that. Why does it get 3 as a parameter? Perfect question. It's that is my divisor. Sorry, I've made a mistake. When I said it was divided by 16, it's actually divided by 8. That's the amount that I bit shift the pixels down by to reduce the brightness. So not 16, it was 8. If I change that to a 4, it would be 16. Have you ever done any Vulkan programming? Yeah, I've done the Vulkan triangle, because you don't want to be too ignorant about these things, but I stopped there. It is what it is. I find Vulkan not that dissimilar to DirectX 12, and I have a little bit more experience in DirectX land, so it's nice that it's there, but I'd probably just do what I want to do in DX12, to be honest. I mean, DX12 is I think it's nice. I like it. It works well as an SDK. Dialects can get confusing, like in Italy, even if you know the dialects. Oh, who have we got? We've got somebody has winked on the emoji, and it's good. It's doing it live, so I'm pleased. Thank you guys. Not everybody's spamming it with lots of like video stuff at the moment. So that's the main program. Isn't that really quite delightfully simple? We initialize the Wi-Fi, we initialize the display, we do some fidgeting about with the tasks and some settings behind the scenes to stop the system collapsing on itself. We configure our WebSocket, and the reason I'm not sort of hiding that information, this is, if you go to the website, you only have to look at the source code. It's all there, right? There's no way I can hide it, and so that's what people have sort of logged into to try and make things work. Where things got complicated, and so once I'd fixed all of this Wi-Fi problem, I then realised I had an additional problem. Right? I don't know much about web development, but what I do know is that I like sort of trying to make sure that people are reassured that if they visit my website, that it's in some way secure. So I actually run everything as HTTPS. Now, I'm well going outside of my territory. So all that stuff I said before about people pretending to know what they talk about, I'm sort of now entering that phase, rather ironically. I don't really know web stuff, and it's not because I sort of belittle it. I do belittle it. I think web is fairly grubby, but it's because I just don't know anything about it. I'm scared of it, and it changes every 3 weeks. So with some trepidation, I sort of embarked on, I've got to do some web development. I've never done any JavaScript, anything. And I threw together a basic WebSocket application. I thought that was easy enough. That was okay. And then I think we do some stream or something a few weeks ago. Maybe it was on the Discord. We were playing around with it. And it didn't work when I put it out on my actual website. And that's because my HTTPS website requires WSS WebSockets. This is opposed to the normal HTTP websites, which don't have any kind of security on them, only requiring bog standard WebSockets, which I'd done everything as bog standard WebSockets. So at that point, I needed to think, well, how the hell am I going to get my microcontroller to actually create a secure tunnel to my web server? And my web server also needed to respond to secure tunnels as well. All of this has been completely done by hand. I say completely done by hand. I've used lots of pre-existing libraries to do it, but trying to figure it all out was an absolute nightmare. So I have to tell my little microcontroller to access my server as if it's the browser. So it does some sort of key exchange in order to do that. And finding this key took a lot of trial and error. And now most people could say, oh, well, what you need to do is, well, what you're going to want to do is click up here, and then you go to the connection properties, and you can actually export the key, right? So that's why it's not hidden information. That's the key you'll export. It's all there. And then I did a little bit of fiddling about, because rather than having the key in source here, I thought it'd be far more convenient if I just have the key as a file. So that sent me on this path of learning how do I actually include sort of data in the ELF file. These things compile to sort of ELF files. How do I include data in there and load it up? And I found some examples of that. So it actually loads things. I think it might actually load it as text. Does it? I can't remember. Let's have a look. What did I end up doing? No, there we are. I'm actually loading it from the file rather than the text, so it's a bit tidy. I can probably get rid of all that. So that was fun and games, and then realised I was using the wrong certificate, of course, because I don't know what I'm doing. I was using, you think you go to these things and that you should use the onelonecoder.com certificate. That would make sense, wouldn't it? But no, what they actually need to do is use the certificate at the top level of the chain, which is provided by my certificate provider, which is Let's Encrypt, like the rest of the world. But no, I had to work that out the hard way. And I'm growling at Bixie, because Bixie's usually the guy that helps me out with these things. But nope, he didn't help me out. So you remember that, Bixie, next time I'm playing your theme tune on this show. Right, that aside, we'll get to the server soon. We've almost finished with the WebSocket stuff. Yeah, exactly. Shame on you, Bixie. Shame on you. When we get to the WebSocket handling stuff, well, here we go. Let's just, what's that looking at? We've still got our emoji. Where's our thing? There it is. Well, his eye is kind of melted. Is somebody hand drawing this, or is somebody actually uploading the imagery? I think somebody's uploaded it because they're using colours that are outside of the palette. And that's you can do that because once you've reverse engineered the protocol, you can send it sort of any colours. It just chops off the bottom 4 bits. But I chose a nice palette here because I found that these rendered well on the display there. Right. Let's just show you that the display is still up and running. There it is. It's sort of an emoji going, ah! It's PNG. Oh, right, so this is Diego sending it. Right, okay. Nice one. Good. So, yeah, it's a shame Rogue's not here, because Rogue also had some scripts. I think he wrote them in Rust or something. The format is very simple. And it's also saying, TW, nobody's done any responsive stuff yet. So if I wanted to draw a pixel like this in the middle of its head, you could technically respond to that and then send other stuff in response. You know, why have we not got falling sand stuff going on and all? Come on, guys, come on, speed it up. Right, let me just jump back into the code. For a second, I'm getting confused with where I need to look. It's getting so many screens. You had ideas about making spells you can draw to cause to make things happen. Well, you know, maybe these are things for a future project. When I've got a few more pixels to play with, we could do these things. This is the event handler for the WebSocket. Let's jump back in there. If you hadn't worked that out already, there's only really sort of 4 types of events that WebSockets get. I thought I hadn't included one there. You get an event when it's connected. You get an event when it disconnects. Now that's quite useful actually, because I guess I don't know how it knows that you've disconnected, because that's one of the biggest unsolved problems with sort of TCP connections, is you don't really know when the other side isn't listening anymore. Maybe it doesn't. Maybe it just fails. Just great. I don't know how it works, but it works. And this is getting the data itself. All of these log functions, they sort of evaporate when you actually build the thing. One of the things I will say for ESP32, and I won't show it tonight because it does mean sort of pulling apart USB cables and things. Once it's actually up and running, you click a single button and it just all works. It builds it, it puts it on the device, and it puts what's called a monitor window on. So you actually, anything that's printed out like this, you can see all of these responses coming up, all at the bottom of the screen here. I've not really tried the step through debugging things. It uses GDB, and yeah, exactly. So here we can see this is when you receive data. Now, my screen doesn't do any kind of data sanitizing at all, mainly because the protocol is somewhat functionally complete. The first character, it's sent as a string, by the way, so it's a 5-character string, including a null terminator, so it's 6 characters in total. So the first 2 characters are the hex of the X and Y locations. Well, there's 16 pixels, so we've got 0 to F in hex. That's perfect. So, and then the second is R, G, and B, and they come through as characters too. And I use them as the most significant bits of the pixel color. And then I simply call my set pixel function. And look at that. I'm sure I remember being able to do that in C, but I sort of rediscovered it by accident. Oh, very nice. So somebody's posted something there. Maybe a bit too big, that image. Some people will be hacking this sort of live, which is what's really cool. They've never done it before, but they'll be sort of looking at the format and working out how to make it work. And you get an event when there's an error, so something goes wrong, you can call it. And that's it. That's all I'm doing. I'm just responding to those sort of 5 text characters coming in, parsing them as appropriate numbers with I had to create a quick hexed int function. And away it goes. Now, if you sent data that didn't abide to that, it's okay. It just basically all zeroes out. Anything it doesn't understand, it zeroes out. And if it does understand it, it just uses it. So it keeps it very simple. Very simple. That's it. That's all there is on the ESP32. I can't think of anything else to sort of talk about on that, other than once I got going with it, the development experience is quite rapid. It is quite a pleasant one to do. It's actually better than a lot of the industrial grade sort of tools I use at work. Oh, that's quite nice. That's a good one. A nice spirally sphere thing. Let me throw the screen back on. That one. I need a special mode, which is bench mode, but close-up microphone. Right, so my voice doesn't keep changing. I'll have to sort that out for next time. Lesson learned. I'm still figuring all this out. So let's go back to monitor mode. So I thought the second, to sort of accompany this, we could go and have a look at some of the server code. But I'm looking at the time and thinking, oh dear, we are kind of running out of time a little bit at the moment. So what I might do is put this back into back into bench mode. There we go. And I can put this on the screen so we can see that live. And whilst that's being drawn, I can turn these lights off. There we go. Immediately goes out of focus. If I bring up the camera settings and stop it from sort of auto-focusing. There we go. Maybe I can just increase the exposure a little bit so we can see a little bit more of what's going on. There we are, that looks quite nice. I'm going to take the filter off. You can actually see just the LEDs behind it. You need the diffusion. I'm looking at that now, and even though I can see that there's clearly distinctly different colours, I can't really make out what the image is at all. It's quite without the diffuser. The diffuser works. It has this lovely lensing effect too. Oh. There we go. So yeah, if you've not played with this, the link is... Oh dear, clonk. We should put the link in again, shouldn't we? So one of the things that I thought was really nice about it is people did sort of reverse engineer all of this straight away. And I was going to try and keep it all sort of closed and just for myself, but I think I quite like the fact that it's I've no idea what's going to end up on this. I will be switching on some of the security features though. So people have been able to sort of play Bad Apple on it and that sort of thing because they can blast hundreds and hundreds of pixels. There we go. Thank you, TW. If you're looking on the website, you'll see it's actually playing it now. But the screen doesn't really update anywhere near as fast. I might try and do something about that, but it's actually incoming data. Every single pixel is being sent. It's queuing up, and it's actually quite a lot of work going through a reasonably slow connection. If I could somehow group those pixels into being a bigger chunk and sending more in one go, yeah, I can quite happily get about 20 frames per second running on the display. So you'll see it's quite latent behind. That's a good example right now. It's still emptying that queue. Those pixel changes haven't been lost. It's just it's running now with quite a bit of latency. So somewhere, either on my server or on my on the input buffer to this, there's just something slowing this down. I've not quite worked out where it is. Well, I'll figure it out. And we may be able to get this running really quite quickly. But when this finishes, and it might take a bit of time, it should go back to what we see on the screen. And that's what I did last time, just by powering it down. And this is a nice test because it shows that the Wi-Fi connection sorts itself out and everything. Let's plug that back in. So it displays Mario for a bit, and then it connected to the server, and it's immediately getting whatever the most recent state is. It does it exactly the same way that the browser does it. The server detects that a new client is connected to it, and then just immediately sends it all of the pixels. It's quite interesting because there's a lot of information going on at the moment, so they're still not quite in sync. There we go. Black on the browser is not quite the same as black on here. I think that's because actually on the browser it's not black. Even though it looks like it, it's actually a very dark grey, and then there's this blurring texture put on top of it which makes it seem very dark. So I'm looking at it on my screen, and I can actually see the display isn't wrong, right? It does actually match what's on the screen. It's just the screen is sort of not gamma corrected, I think. There we go. Yes, kind of. I think one's like a very sort of dark brown, and one's a very dark blue. And so if I pick the dark blue one and put that one in, that's the dark blue one. And if I pick the dark brown one, that's the well. See, it's actually quite red on there. It's one of the things that we've had some brief discussions on the server about gamma correction for this. Of course, I can't display black, and the printed membrane that sits on all of this, you can't see it there, but if I hold it up to this one, is actually white. So in order to make it appear black, you kind of fill in the negative space with your own mind. It was interesting when Mario's on there. You can actually you can determine Mario has a moustache and it looks black, but the reality is it's displaying a white pixel. It's quite crazy stuff. So your brain's very good at making things look darker than they really are. I don't know what that effect is called. It'd be interesting. I'm sure somebody can dig that out. Right, we didn't get time today to do server stuff, did we? That's a shame. Where's my thing? Where's my camera? There we go. We didn't get time today to do server stuff, which is a shame because that's what I think we'll probably talk about next week. Because there's an opportunity to actually tidy up the server code. It's a complete mess. And I had to learn something new to do the server code too. I learned how to do the WebSocket server. I'm using something called Zaphoids or Zaphods WebSocket library for that. I had to learn about TLS and security stuff. That was quite confusing. What else did I have? Oh, I had to learn how to use Visual Studio Code's remote development. Now, I don't like Visual Studio Code. I think it's amateur. But I will give them the credit that actually the remote development experience is actually the best I've used. They've really nailed that down. That works very, very well indeed. So until then, thank you for watching. I hope you're enjoying my project. I'll keep posting some updates on Discord. Over the Christmas period, I'm going to be creating a few videos to put up next year, so hopefully the channel's back in action. And so until then, I'll see you all next time. Take care.